Good morning. In this lesson, we talk about health and climate profile model. Ambient temperatures, among other environmental factors, have been shown to be linked to morbidity and mortality. To understand the relationship amongst local microclimate, buildings, and outdoor comfort, we often use modeling techniques to determine the thermodynamic interdependency amongst these fields. Parametric analysis can provide helpful support on various urban thermal conditions through a simple graphical representation. Moreover, in urban planning, it is important to take health into account. In this activity, we show an example of integration between urban planning and health in creating a climate and health profile (CHP) model to identify possible health risks in the urban environment today and in the future. A climate model is a computer program designed to simulate Earth's climate to understand and predict its behavior. Climate models are largely based on a set of mathematical equations that describe the physical laws which govern the behavior of the atmosphere and ocean, and their interactions with other parts of Earth's climate system. For example, and surface and ice sheets. Global climate models simulate the interactions among the atmosphere, ocean, land surface, and ice in coarse resolution. Global climate models resolution is too coarse to provide actionable climate change information at the local scale. Regional climate models, RCM, focusing on a smaller area, can provide higher resolution climate data, up to 500 meters. To run RCM, the input climate data for their simulation needs to be tuned. This process is called downscaling. Urban growth affects the atmospheric processes, developing consequently distinct urban climates, which vary over different time and horizontal space scales. The parameterizations adopted by regional climate models cannot capture all the features and the fluxes flowing through the city. Modeling of the microclimate is needed to have a very high-resolution representation of urban and built environment behavior under climate-induced phenomena. Phenomena such as urban heat island effects are largely studied through this approach, and common tools include ENVI-MET, Raman, Autodesk, Ladybug, etc. The study of the effect of climate on the human body defines human bioclimatology. The general well-being of individuals is affected considerably by the bioclimatic conditions. The need for human thermal balance modeling resulted in the development of bioclimatic models. Common indicators computed by bioclimatic models are the Universal Thermal Climate Index, UTCI, and Physiological Equivalent Temperature, PET. The climate analysis tools have user-friendly interface. They are based on the Ladybug tools, a robust climate analysis software suite known for its power and difficulty. With these tools, the canonical learning curve flattens out. Teaching becomes simple, allowing anyone to use climate analysis without investing a lot of time in learning how to use it. The developed user interface is simplified and makes climate analysis easy and intuitive, guaranteeing accurate and reliable results. The software interface is divided into colored sections, each of which has a specific purpose. The user can quickly access the areas of interest to perform the analysis. In addition, when data processing is complete, the software returns a result that can be displayed on the screen or saved to a file. In this way, the user can immediately view the results of the analysis or archive them for future use. The Weather Data to EPW tool allows large amounts of weather data to be managed with minimum effort. The second climate analysis tool, Representative Day, also features a simplified user interface. It is designed to perform a statistical investigation of previously acquired meteorological data in order to identify a representative climate scenario for the case study. It provides a series of graphs showing the climatic trends of the representative day and the least representative day. This output allows the user to quickly assess weather conditions and make decisions based on the analyzed data. The third tool is named Morph. This tool requires to provide some geometric information about the area of interest, such as building characteristics, soil type, and vegetation. In addition, the user must specify the intensity of anthropogenic activities in the area. Once this information is provided, the software performs a morphing of the meteorological information contained in the EPW file, adapting it to the urban area. The core of the software is based on UWG Urban Weather Generator, a powerful model developed by MIT for urban heat island assessment. The output of this tool is a new EPW file that considers the effects of the urban heat island on the study area. This file can be used to obtain more accurate and realistic results. The fourth tool, named Analyze, collects all the data processed by the previous tools. This tool is designed to provide detailed maps of shadows, solar radiation, and comfort analysis. The aim is to allow an accurate analysis of the area, enabling the user to make planning decisions. A tutorial is available for help using the described tools. The purpose of this activity is to educate students on the specific impacts of climate change in cities on human health, digital tools to simulate urban environments, and the assessment of thermal comfort based on international indicators. Climate change is a global problem that has significant effects on human health. However, its impacts on cities and urban communities are often overlooked. That's why it's important to educate students on how climate change affects human health in cities. In this activity, students will have the opportunity to learn through digital tools that allow them to simulate the urban environment. These tools enable the evaluation of the impacts of climate change on human health, particularly regarding thermal comfort. Furthermore, students will be exposed to international indicators used to assess thermal comfort and encouraged to develop a critical understanding of the manifestations. By using in more depth specific indicators of climate and health, students are exposed to the multiple aspects of climate change, from the configuration of the built environment to the physiological response of the human body. Each delivery option is designed to allow students to present their results effectively and consistently with their individual learning styles. Various media can be used to provide a visual analysis of the results, while a flowchart can be helpful to provide a quick and simple visualization of the work process undertaken. Outdoor comfort maps can be used to provide a detailed analysis of the results of UTCI analysis conducted by the students group. An oral and design presentation of the developed activities is a great option for students who prefer to express themselves creatively. Finally, the written report can be used to highlight the strengths and weaknesses of the health learning activities in the city profile. In this way, students can reflect on their experience and suggest any improvements for future activities. By achieving these learning outcomes, students will be better equipped to understand and address the challenges posed by climate change in urban environments. Additionally, they will be able to apply their knowledge and skills to create more sustainable, healthy, and livable cities in the future. Methodology tools are literature study. Students will have to study materials provided to them in order to fully prepare for lecture workshop. Background literature on urban challenges, climate change, urban health. Previous literature on the link between climate and health indicators. Additional material provided by teachers on the basis of the teacher's competence. Digital tools. The Ladybug suite will be used to assess present and future meteorological scenarios. The Ladybug suite of tools will be used to examine the impacts of the outdoor built environment on human thermal stress. Interviews for the construction of the health profile of the neighborhood. The students will administer to the citizens or stakeholders and administrators who will participate in the local workshops, and to those who can be reached via the neighborhood's website or Facebook a questionnaire for the definition of the neighborhood health profile. The City Health Profile questionnaire will be administered to citizens and institutions in order to assess their knowledge about the perception of health risks in urban settings. The questionnaire is divided into 4 sections: socio-demographic information, risk perception, soft skills regarding attitudes towards climate change, and, finally, willingness to pay, to find out how much citizens expect to spend to cope with climate change, and how much they are in favor of a possible tax increase to counteract the effects of climate change. Pedagogical activities are lecture. A lecture will familiarize students with the impacts of climate change in cities on the health of humans and how challenges can be addressed. Seminar. Quick seminars will improve basic knowledge of the urban environment, thermal comfort, meteorological aspects, climate issues, and so on. Thematic focus on one of the health topics, for example Green's assessment, health impact, with a PowerPoint presentation of 45 minutes, and support bibliographic material given with the aim to give a deep improvement of the knowledge. Laboratory. Digital tools may be used to illustrate how the city fabric affects human health. Parametric tools may be used to evaluate meteorological scenarios and address the urban heat island and the urban overheating. Group study. In-depth analysis on one of the health topics, for example Green's assessment, health impact, with support bibliographic material given with the aim to give a deep improvement of the self-knowledge.